Okay, so today we are going to talk about section 5.2. And we will learn about this thing called the unit circle that will be our best friend. And also then the sine and the cosine function. Turns out these are another one of our basic functions that we'll need to know about. So first let's talk about a unit circle. Let's say on the Cartesian plane, if this is x and this is y, let's put a circle of radius 1. Okay. That would mean then that this is a unit circle. A unit circle is a circle of radius 1. It's our most basic circle. Well, so what does that mean? We know a few points then. We know that this is the point 1, 0, and this is the point 0, 1. This would be the point -1, 0, and this would be the point 0, -1. And those are the only points that we know for sure at the moment. So let's put in a ray, and that will cut off an angle in between the x-axis and this ray. Let's call that angle alpha. And it will cut the unit circle on this point in x, y. And why is that helpful for us? Well, then we have a few definitions. The cosine of alpha then is x. So whatever point here, that will be the cosine of x. Another way to say this, the cosine of alpha is equal to x. And the sine of alpha is y. Another way we could say that is that the cosine of alpha is equal to y. Okay, so these are our definitions. Okay. And this is true when we're on a unit circle. This is not true if we're on a circle that's larger than that. And we should probably make this note, okay? So when we're talking about the domain of these functions, what we're talking about is what we're putting into the cosine. Oh, I'm sorry, this should read sine. Sorry, you guys. S-I-N. So into the cosine we put an angle, into the sine we also put an angle. So the domain here are angles, and that'll be important for us to remember. And what will come out then is the range, and this will be our x's and y's, and these could be ratios. All right. We'll see that in a few minutes. Okay. So for right now, let's just use these definitions and try and find some examples. Okay, so for example, if I took the sine of pi over 2, what does that have to equal? Well, first of all, I come back up to the unit circle, and I find pi over 2. So the angle pi over 2 is this angle, and it terminates here. I need the sine of that, and by definition, the sine is the y value. So we can say then that the sine of pi over 2 is equal to 1. Similarly, then, the cosine of pi over 2, we would be looking at the x value, and that would be equal to 0. We could look at the sine of negative 180 degrees. We can still do that. Here is the positive 180 degrees. We'll need the negative. We come here, and we find the sine of this value. So the sine is the y value, so that's equal to 0. And if we looked at the cosine, that has to be the x value, so that's equal to negative 1. Let's try another. The sine of negative 3 pi over 2. So now I'm again working in the negative rotation. So this is negative pi over 2, negative 2 pi's over 2, negative 3 pi's over 2 is where this angle will terminate. Okay. Now the sine of that is the y value, and so that is 1. We could look at the cosine of a negative pi over 2. So again, I'm going in the negative rotation. Here is negative pi over 2, and the cosine is the x value, so that must be 0. Okay, so that's how we do it by reading the unit circle. So there's a direct implication since the x and the y are the sines and the cosines. Let's look at what that would be. Remember, we have 4 quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. This is the x, this is the y. Remember, our x is the cosine. So if I'm going to be in quadrant 1, I would have to go positive, and therefore the cosine of the x would also have to be positive, or we could say alpha, it doesn't matter. So it would have to be greater than 0. Similarly, we'd have to go positive in the y, so the sine of alpha would here be, again, positive. Now, to get to quadrant 2, I would have to go negative in the x direction, which now means that the cosine of alpha is less than 0. But I would still stay positive in the y, so the sine of alpha would be greater than 0. To be in quadrant 3, I'd have to go negative in the x and the y, so both the cosine of alpha and the sine of alpha have to be less than 0. To be in the 4th quadrant, I would go positive in the x. So the cosine of alpha would be greater than 0, but the sine of alpha would have to be less than 0. So this is just a good idea to keep inside your head about what must be happening with the values of the sine and cosine. Okay, so let's look at the multiples of 45 degrees. We did this yesterday. Okay, we said we could subdivide the circle by putting in the 45 degree angles here. So this angle was 45 degrees, then this was 90, this one is 135, then plus 45 got us to 180, plus another 45 was 225, 270, and finally 315 degrees. Okay. So now what is it about the sine and the cosine here? Like, what exactly is this point, this x and y, that we're looking for? Because if we could find them, then I would know the sine of 45 degrees and the cosine. So the way we're going to do that is that we can drop what's called an altitude, a straight line here, and it would form a triangle here. And specifically, it would be a right triangle. Let me pull that out so we can see it. Now, we don't know much about this circle, but I do know this. The hypotenuse has to be the radius. Okay. Now, I'm on a unit circle, so the radius is 1. Since I have a right triangle, I can use Pythagorean theorem to find out what our x and y are, because specifically to get to this point, I had to go some direction in the x and some direction in the y, which means that x and y are here. Now, we know that this angle here is 45 degrees. So, we also know that this angle is 45. How do we know that? Well, in a triangle, the sum of the angles has to be 180 degrees. If this one's 90, and if this one's 45, then say we didn't know this one, b minus x. So x would be equal to 180 minus 90 minus, this is a plus sign here, 90 plus 45 plus x. Okay. So when I subtract, I'm subtracting 90 degrees and 45 degrees. Okay. 180 minus 90 is 90 degrees. 90 minus 45 is 45. So this angle must be 45 degrees. All right. Now, why is that helpful to us? Well, then we know this, remember from geometry, that if two angles are equal, the sides opposite them must also be equal. Okay? So really, it's that our triangle now looks like this. It's 90 degrees. This is 45. This side is 1, and since these two are equal, I can just relabel them x and x, because these two are equal. Now we can use Pythagorean theorem that says the hypotenuse squared must be equal to a squared plus b squared. So 1 squared is 1. And if I have an x squared plus an x squared, I have 2x squares. This will let us solve for x. Let's divide through by 2. So we would have 1/2 is equal to x squared. And now I need to take the square root of both sides. So x is equal to plus or minus the square root of 1 over 2. Now I'm in the first quadrant, so everything will be positive, so I'll keep this. So we know that x must be equal to the positive square root of 1 over 2. And now let's simplify this using the rule for radicals and quotients. That's the same as the square root of 1 over the square root of 2. But the square root of 1 is just 1 over the square root of 2. And now we'd like to rationalize this. So I could multiply by the square root of 2 over the square root of 2. So 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2 is square root of 2 squared. So now x must be equal to the square root of 2. Well, the square root of 2 squared is just 2. So this is our x value. That means the length that I've gone here is the square root of 2 over 2. And since y is the same, the height is the square root of 2 over 2. I hope this makes sense. Now the same triangle here in green, notice I could just flip it over and determine this point. That would be available in there. There's the triangle again. So this triangle, I simply flip over. These are the same y coordinate. The only thing that's different now, I've gone the same distance in x, but this time I've gone negative. So this is the point negative square root of 2 over 2, positive square roots of 2 over 2. And we can keep going like this to find these 2 points. I could take this triangle that we just found, okay, and now flip it downwards, and the same thing would occur. The length of the sides of the triangles will stay the same. It's just now I've got negative in the x and in the y. So this is negative square roots of 2 over 2, comma, negative square roots of 2 over 2. Then we could flip this triangle one more time, bring it over here. Oops. The length will stay the same. I'll just change the orientation of it. So I've gone positive in the x, so positive square roots of 2 over 2, and negative square roots of 2 over 2. I hope this makes sense. So now let's try and answer some questions. Let me redraw this. The more times you redraw your unit circle, the more quickly you will be able to learn it. Okay. So this was square roots of 2 over 2 and square roots of 2 over 2. Okay. This is the angle 45 degrees, but remember that's also pi over 4. Okay. So 1 pi over 4, 2 pi's over 4, this is 3 pi's over 4, and this is 4 pi's over 4, which is just pi. This is 5 pi's over 4, 6 pi's over 4, 7 pi's over 4, and 0 or 2 pi, however you'd like to look at that. Okay, so if we know these things, this is our basic, that's what we'll call a reference angle here, is pi over 4. We'll talk about that in a minute. Okay, so if we need to know the sine of 5 pi over 4, I know it's simply, here's 5 pi over 4, it's simply a reflection of this. So this coordinate is where I've gone negative in the x and negative in the y. Okay. So the sine of 5 pi over 4 is the y value. It must be equal to negative square roots of 2 over 2. And we can mix them together too. What if we had 2 times the sine of 7 pi over 4 times the cosine of 7 pi over 4? Okay, so this is all multiplication. 2 is just a coefficient, so it's 2 times the sine of pi over 4, and we multiply that by the cosine. So our 2 will just come down, and we're multiplying that by the sine of 7 pi over 4. Well, here's 7 pi over 4. Here I've gone positive in the x, so this is positive square roots of 2 over 2, but I had to drop down negative in the y, so negative square roots of 2 over 2. Okay. And the sine is the y value, So we're multiplying by negative square roots of 2 over 2. And our cosine here is the x value. So we multiply that by square root of 2 over 2. Now we can think about this as 2 over 1 if you'd like. And we can do some canceling. These two will cancel. And then from up top, we have negative, and then the square root of 2 times the square root of 2 is 2, all over simply 2. So we get negative 1. So that's how you attack these type of problems. Understand that it's multiplication, and do your simplifying. Now there are other angles that will be very easy for us to look at. So if this is 90 degrees, a very easy angle for us to find would be here at 30 degrees, and then also up here at 60 degrees. Okay, so we're trisecting the angle of 90 degrees. Alright, how are we going to do that? Well, let's look at an equilateral triangle. Okay, so an equilateral triangle has sides that are all the same. Okay. Now, if the sides are all the same, all of these angles must be the same. This must be 60 degrees, 60 degrees. This one's also 60 degrees. I could drop an altitude here that would bisect. And then the length from here to here must be 1/2. Also, then the length from here to here must be 1/2. Because if I'm bisecting one, half goes here and half goes there. So then, while this total angle is 60, what that means is this angle between here and here is 30 degrees. And this angle between here is 30 degrees. So if I look at just one of these, let's just pull out the green one. This is 60 degrees. This is 30 degrees. We know the length of this side is 1, and this side is 1/2. And we're just not sure what this side is, the length of this side. But we can solve it. Okay. This is known as a 30, 60, 90 degree triangle. So again, let's use Pythagorean's theorems. We know that 1 squared must be equal to 1/2 squared plus y squared. So 1 must be equal to 1/2 times 1/2 is 1/4 plus y squared. And if we subtract 1/4 from both sides, we get 3/4 on this side is equal to y squared. And now we'll take the square root. So we'll get plus or minus the square root of 3 over 4 is equal to y. And now, let's do the same trick that we did before. We're going to be in the first quadrant, so let's just take the positive for right now. Then this becomes the square root of 3 over the square root of 4, splitting up the radical with the quotient, which is the square root of 3 over 2. So what does that tell us? Well, if we're on a unit circle, the radius is length 1, I could cut out this triangle and put it in here because this angle is 60 degrees. Then this ordered pair means that I went 1/2 in the x and then up square roots of 3 over 2 in the y. Now notice, though, that I could also fit this 30-degree triangle in. Okay, so let's see if I can draw that. So if I want the 30 degrees to be here, now this is the 60 degree. The hypotenuse is still 1. Now the shorter side of the triangle needs to be opposite the smaller angle, which it is. So this is now 1/2. And the larger side is opposite the larger angle. So here we would now have the square roots of 3 over 2. So what that means is if I picked this up and put it inside of here, I would have gone square roots of 3 over 2 in the x, and then up 1/2 in the y. So this is why the 30, 60, 90 triangle is very easy for us to work with. Okay. So now let's put in the multiples. So this is the multiples of 30 degrees and 60 degrees. Okay, so let's see. I've done the 30 degrees in blue, so that triangle would come here. I could flip that over to a point here. Now here's the triangle. If this is 30, this also has to be 30. All the way around is 180, so 180 minus 30 is 150 degrees. And its coordinates now are negative in the x, so negative square roots of 3 over 2, and then positive 1/2. Then if we flip it down, then here is 30 degrees, so 180 plus 30 is 210 degrees. And now both coordinates are negative. And we could flip this triangle again to come right over here. If all the way around is 360, then this would be 330 degrees. And its coordinates are positive in the x and negative in the y. Okay. Now let's fill in the green. Here's our triangle there now. Now it could flip over and we would get a point here. The triangle would be inside of here. So this is 30, this is 60, this is 90, this is 120 degrees. Okay. I've gone negative 1/2 in the x, and now positive square roots of 3 over 2 in the y. We could flip it down. There would be a place here and here. Let's see here. So 180, 310 plus 240. And now I've gone negative in both the x and the y. So negative 1/2 and negative square roots of 3 over 2. And lastly, we could flip it over here. So plus 30 is 270, plus 30 is 300 degrees. Okay. Now we've gone positive in the x and negative in the y. Now when you put the two of these together, well, I guess all three of them are endpoints plus this, plus the multiples of 45, also known as pi over 4. When you put all those together, you get a unit circle. And this is a unit circle that this unit circle is going to be so important in trig. It needs to be our best friend. So we need to get that memorized right away. We've just derived it. I suggest you try and do it a couple times on your own so you can understand what's happening. We're going to need to know how to do these in degrees and also in radians. Okay, so, and I will show you how to do that in a moment. X squared plus y squared equals 1. That's true, that's true. Okay, so let's look at how we can subdivide this in radians, okay? Because that'll be important for us. Okay. So let's put in what we know. We know that this is 0, that this is pi. Half of pi is pi over 2. So pi over 2, 2 pi's over 2, 3 pi's over 2, 2 pi's over 2. Let's say I did this in blue. Now, remember then we trisected things. Okay? We did one in the blue and the green. Okay, so we trisected this angle pi over 2. Okay, well, what is that? Well, this angle has to be from here to here. It's 30 degrees. In degrees, it was very easy for us to see. We just took 90 and we divided it by 3 to get 30. Well, that's fine. We can do the same thing here. Let's take pi over 2 and divide that by 3. So what is pi over 2 divided by 3? You might want to think about that as 3 over 1. Remember, when you're dividing fractions, it's the same thing as inverting and multiplying. So this angle is pi over 6. What about the green angle? Well, the green angle is just 30 degrees plus 30 degrees. Okay. So the same will happen here. This angle has to be what we found, pi over 6, plus another pi over 6, which is 2 pi's over 6, which reduces to pi over 3. Okay, so just treat those pi's like you would a radical or a variable. And then, if we're right, then pi over 2 should be simply pi over 3 plus another pi over 6. And it is. If we get a common denominator here, we have then that pi over 2 is 2 pi's over 6 plus a pi over 6, which is 3 pi's over 6. And 3 pi's over 6 is 1/2. Okay, pi over 2. So that's going to help us find these other points as well. Let's just count it out. If this is 1 pi over 6, this was 2 pi's over 6, this is 3 pi's over 6, this one has to be 4 pi's over 6, this is 5 pi's over 6, pi is just 6 pi's over 6, 7 pi's over 6, 8 pi's over 6, this is 9 pi over 6, okay, because this just reduces to 3 halves. So this is 10 pi over 6, 11 pi over 6, and this is 0 or 2 pi, which is 12 pi's over 6. And then usually we would do the reducing. So, for example, 2 pi's over 6 we'd call pi over 3, 4 pi's over 6, there's a common factor of 2, so we reduce that to 2 pi over 3. Here we have another common factor of 2, so this is 4 pi's over 3, and a common factor of 2 here, so this is 5 pi's over 3. Okay. Yes. All right. And we filled in all the different, their ratios. Okay, so let's start doing some examples. All right. For example, let's find the sine of 5 pi over 6. Now, 5 pi over 6 is over here, so I know I'm going to have to be negative in the x direction and positive in the y. Y is the sine, so I'll take the positive 1. And the way I always do this is I envision, where does this triangle lie? Okay? Well, to get there, I would have to go longer in the x and shorter in the y. So that means the square roots of 3 over 2 is this side, and we're in the negative direction, and then the positive 1/2. So here's where the triangle would be. We could also think about the cosine of 5 pi over 3. Now the cosine of 5 pi over 3, 5 pi over 3 is here, so if I was to put in the triangle, I would go very short in the x direction and then long in the y direction. Okay. So the short sides of the triangles are the 1/2, and the longer sides are the square roots of 3 over 2. However, I'm in the negative direction here, so it's negative square roots of 3 over 2. What if I wanted to find, if we had this, and I put a squared there, of 4 pi over 3? Okay, so we have to be careful and learn this notation. Okay? This is how we write squaring trig functions. Okay? So what that means is that you take the sine of 4 pi over 3, and then when you're done, you square it. So what is the sine of 4 pi over 3? Okay, well 4 pi over 3 is here. Right? So if I wanted to get there, I would have to go short in the x and long in the y for the triangle. Okay. And I'm looking for the sine, which is the y value. So this is negative square roots of 3 over 2. And that makes sense that these two have the same cosine values because they're on the same level. Okay. And then we have to square that. So that's negative square roots of 3 over 2 times negative square roots of 3 over 2. The negative and negative become positive. Square root of 3 times the square root of 3 is 3, and 2 times 2 is 4. So that's how we would do that one. There's another way to do this that your book talks about. I always think about just how these triangles are lying in the sides of the triangles. There's another way called the reference angle. So let's talk briefly about that. So, the reference angle for theta, okay, for any given angle, is the positive acute angle, and we're going to call this theta prime because they're related, that is formed by the terminal side of theta and the x-axis. Okay, so for example, let's find the sine of 225 degrees. we find out where our angle would be. 225 degrees is 180 plus another 45. Okay, so this is 225 degrees. Okay. This is our angle theta that we're talking about. Okay, this is theta in our definition. Okay. This is 225 plus another 45. But notice what I said was plus another 45. Okay. So this angle in between the x-axis and the terminal side is the reference angle. So this is theta prime. Now the thing about theta and theta prime, your angle theta that you're actually looking for in this reference angle, is that they're only going to be off by a sign. And by a sign, I mean an S-I-G-N. Okay? They can differ at most by a sign, S-I-G-N change. So what we're really looking here then is, this is the idea what I was drawing in the unit circle earlier. I was drawing in, so if I was looking for 225, I would realize that the triangle lies in here, and I'd be referencing the triangle for 45 degrees up here. Remember I said that since these are equal, this was square roots of 2 over 2, square roots of 2 over 2. And the way I was doing it, I was saying, okay, so we'll flip it over, so the coordinates will stay the same, except now since we're in the third quadrant, both of them become negative. So the sine of, this is what they mean by the reference angle method. So the sine of 225 degrees, I reference the sine of 45 degrees, which is square root of 2 over 2, but I have to make it negative to remember which quadrant I'm in. So let's do another one. What if we had the sine of 7 pi over 6? Okay, so the first thing I do is I find out where 7 pi over 6 lies. Okay, well, I know this is 6 pi's over 6, so I have to go an additional pi over 6 to get to 7 pi's over 6. Okay. So that additional place that first is our theta. This is 7 pi's over 6. And then our reference angle is here, and I said I was going here, 6 pi's over 6, and I needed to go an additional pi over 6. So that's our reference angle. So what we know then is, now pi over 6 is here. Now the way I do it is I say, okay, the long side of the triangle is square roots of 3 over 2, and then I go up 1/2. And then I just remember if I was going to flip this, then I would still have to go negative, or square roots of 3 over 2, negative, to be in the third quadrant, and then to come down would also be negative 1/2. So in this way, the sine of 7 pi over 6 is equal to the opposite of the sine of pi over 6, which is negative 1/2. So the sine of pi over 6 is 1/2. The negative of that is negative 1/2. So this is what they're talking about in your homework when they ask you for the reference angle. Alright, let's talk about the other best friend that you will have in this course. Okay, so here's our unit circle. I know it's a unit circle because here's 1, 0, 0, 1. Okay. We have any given angle inside of here. We'll cut off a point x and y. Okay. So what's the equation of this circle? Well, remember, the basic form of any circle, as long as it's centered at the origin, is x squared plus y squared equals r squared. Now in our case, r is equal to 1, but 1 squared is just 1, so the equation of this circle is x squared plus y squared equals 1. Now, let's mix what we know from algebra with what we've just learned in trigonometry. We've said that the x values were the cosine values. So I could rewrite this as cosine squared of alpha. Let's call this alpha just to be clear. Okay. Then plus y squared. Well, we said the y was the sine, so we write that sine squared of alpha must be equal to 1. Okay. This will be our best friend. So the number 1 is very helpful for us because it's the multiplicative identity. We can multiply anything by 1 and not change the value. What that means then is that we could multiply anything. Notice these are the same angle, okay? Of the cosine squared alpha plus sine squared alpha, and we would be multiplying by 1. Also, anytime we see cosine squared alpha plus sine squared alpha, we can automatically replace it with 1 to reduce and simplify what we're working with. Some people call this the fundamental identity of trigonometry. It's an identity because it'll be true as long as you put the same values for the variable in here. Okay. Also remember, these are trig functions, so the values of the variables. The domain is angles. So let's see how we might solve an equation. So let's say, for example, we have the cosine of alpha is equal to negative 4/5. Now I need more information than just that because I don't know exactly where I'm at. Okay? It could be, if the cosine of alpha is negative 4/5, well, all I know is that I'm going negative this direction. I don't know if I'm in quadrant 2 or in quadrant 3. It could be in either place. So in this, you'll need to be told where alpha is. And alpha is in 3. Okay, let's think about another way we could say this as an aside. Well, if you're in quadrant 3, this is 180, and this is 270. So theta needs to be in, or not theta, alpha needs to be in there. If we do, that's another way of saying alpha's in 3. Another way would say, well, this is pi less than, and this is 3 pi over 2. These are all ways to say that alpha's in 3. Okay, so we know we're going to be in here. So now the question becomes, let's find the sine of theta. I'm sorry, alpha. So if this is all the information I have to find this. And the way that we'll do that is we'll use our fundamental theorem. We know that cosine squared of alpha plus sine squared of alpha, okay, and notice I can put parentheses around these or not, you don't have to, is equal to 1. Okay. But what is cosine of alpha? It's negative 4/5. So negative 4/5 is alpha, and remember that notation says we're going to square it, plus sine squared of alpha equals 1. So this is what I'm looking for. Well, I'm looking for sine. Okay. So let's square this. Negative 4 and negative 4 become positive 16. And 5 times 5 is 25. Plus sine squared of alpha is equal to 1. Now, I'm going to subtract negative 16/25 from both sides, so it'll cancel on this side. And I just want to rewrite 1, because clearly we have a fraction here, as 25 over 25. So we know that sine squared of alpha would be equal to 9. 25 minus 16, yes, is 9 over 25. Now, I don't want sine squared. I was asked about just sine, so we can take the square root just as we would in algebra. Then we'll just be left with the sine of alpha is equal to plus or minus. And let's split this up while we're at it, because the square root of 9 is a perfect square and the square root of 25. Now, we're not quite finished. So which is our answer? Is it the plus or is it the minus? We'll reduce this in just a second. Well, for that, I have to go back and find out where we were at. Alpha is in quadrant 3. So if alpha is in quadrant 3, our angle, which should we pick, the positive or the negative? Well, to be in the second or the third quadrant, you have to go negative in the x and negative in the y. So we'll take the negative. Okay. So this becomes negative, and now the square root of 9 is 3, and the square root of 25 is 5. I hope that makes sense. So that's how you do these types of problems. Let's do one more problem. Let's say we had 3 times the cosine of pi over 6 times sine squared of negative pi over 3. Okay, so there's a lot going on here, right? Remember, this is 3 times the cosine of pi over 6 times the sine of negative pi over 3, and then squared. So that's what this notation means. It's here. Alright, so let's see if we can figure that out. Alright, so the 3 is going to come along. Then I have to multiply that by the cosine of pi over 6. Okay, so pi over 6 is right here. I have to go the long way and then up short. Okay, so this is the point square roots of 3 over 2, 1/2. And I'm looking for the cosine of pi over 6. So the cosine is the x value, which is square roots of 3 over 2. Now here, for negative pi over 3, okay, that's negative 2 pi's over 6. If that's 1 pi over 6, then here's negative 2 pi's over 6. So to get there, I have to go short and then long. So this is positive 1/2, negative square roots of 3 over 2 for the angle negative pi over 3. So now we have to multiply that by, I need the sine. Well, the sine is the y value, negative square roots of 3 over 2, and that has to be squared. Now we're almost finished. Okay, think about this as 3 over 1. So this is 3 square roots of 3 over 2 times, now I have to square this. The negative and negative will become positive. Square root of 3 times square root of 3 is 3, and 2 times 2 is 4. So in the end, 3 times 3 is 9, square roots of 3 over 8. Alright, so just be careful with what you're doing. It takes good bookkeeping skills. Right? Do not use a calculator on your homework. You'll be asked for exact values. Okay? Don't approximate what this square root of 3 is. because we will be taking this test without a calculator. So again, keep doing your homework without your calculator. I hope this helps. Email me if you need me.